Hello, welcome back to another live set class. We are today being Friday. We are in CSEC paper 2, past paper 2, and we're going to be going up to 8 o'clock. So, or until the questions run out. All right, so I'm going to be playing now the schedule is so that you can write down the schedule and you know exactly when to tune in, whether it's PEP classes or the CSEC classes. Hello, CSEC math students. I know you are busy preparing for your math tests, CSEC exams coming up. I have a very, very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands have. Now, in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC math. We're going to look at the common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those. So stay tuned. Hello, did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you? All right, so we're going to get going now. So let me share my screen so you can see the question that we're going to be looking at. Okay, so here's our first question. In the diagram shown below.
We're not seeing the screen. We're not seeing the screen.
We're not seeing the screen yet?
No, miss, we're not seeing the question. No, miss.
I shared it. Hold on. All right, let me share that. Let me do it again. See it now?
Yes, miss, it's loading. Yes, miss, it's on now.
It's loaded.
All right. Okay. So in the diagram shown below, ABCDE is a pentagon. Angle BAE is 108 degrees. Angle ABC is 90 degrees. Angle AED is equal to 80 degrees. Angle ADC is equal to 57 degrees. And angle AE is parallel to CD. Sorry, not angle. Side AE is parallel to CE. So they
CD,
want
miss.
us to calculate CD. So they want us to calculate the size of the angles marked X and Y degrees. So for I, we need to find angle X, and for II, we need to find angle Y. So take a minute to study the diagram and then tell me any ideas that come to you. An important note there is that AE and CD are parallel.
Parallel, miss.
Okay, they are parallel to each other. So that's going to be important. So how can we find angle X?
Miss, because since the angles are parallel, would they be the
The
combined
lengths are parallel.
le- yes, miss, the length? Would it be that x and 57 would equal the same thing as 108 degrees?
The X and the 57 would be the same as what?
108 degrees, or that would work.
No. The fact that they are parallel means that you see that line that cuts across the two parallel lines?
Yes,
The
miss.
line from A to D,
Yes, miss.
that will create what we call alternate angles, or some people call them Z angles. So
Oh,
it would mean that angle EAD, follow where I'm going, E to A to D, that angle would be the same as a 57 because they are
miss.
alternate angles. They are at the corners of the Z, put it that way.
Yes, miss. Miss, that's
So
what I
if we
was.
know that EAD is 57, how can we use that to find angle X?
Miss X would be 51 degrees.
How you got that?
Miss, because they're, what do you call it? You just said it. The Z
Alternate,
angles,
yeah.
alternate angles.
They're alternate angles.
Miss, the 57 would be the part, would be EAD, and um, wait. Oh, wait. I don't know. I don't understand how to explain it.
Rayshon, any ideas?
It.
So I'm still looking at it.
Any ideas on how to find angle X?
I'm still looking at it. Mm,
From Zion, good night. So we're saying EAD is 57 because the transversal cuts the two parallel lines and creates alternate angle. EAD is equal to 57. So if you focus now on the triangular part of the diagram, knowing that EAD is 57, what
Miss,
can we do to find X?
oh, Miss, so EAD would be 57, and the other part of the angle would make up for 108. So the other part of the angle would be 51 degrees. The part that would be DAB would be 51 degrees, and they add up to give 108 degrees.
But how you know that DAB 1?
Miss, because EAD is 57 degrees, and there, because it's one big angle and it's split into two.
So we're focusing on the triangle. We know one angle is 57. We know the other one is what? 80, right?
Yes, miss.
Mrs. X80.
So the 57, add the 57 and the 80 and
Oh, okay.
take it from 180 and you will get X. So
147
do
from
that.
100. Oh,
So
Miss,
it's
would
the
it be
So
43?
57,
Miss, would it be 43?
Yeah.
right? So 43. So X is 43 degrees. Now, how would we find Y?
Miss, Miss already give us angle B, which is a 90-degree angle, miss, because of the square.
Yeah.
Is this the one?
Yeah, what?
So how would
90.
we find Y?
Miss, with the 90 degrees plus the 57 degrees.
Speak
Then
up,
one.
John.
Yes, sir. Miss, Mister already gave us the indication that one part is a 90-degree angle, miss. Miss, so it would be 90 degrees
Yes.
7 plus 57 degrees, which give 147 from 180 degrees, which which would give 33.
But why are you taking it from 180 degrees?
Because not a triangle.
Uh,
What's the name of that polygon that we're dealing with now?
it's not a
Miss,
triangle.
that's the quadrilateral.
It's a quadrilateral.
So
So
everything
quadrilateral.
would
angles
add
in a quadrilateral add
360
up to what?
degrees. 360
Huh?
degrees.
Angles in a quadrilateral add to 360
Oh,
degrees.
Yes,
Okay.
miss.
So
So
we
miss,
need to add the three angles
And
that we know and take it from 360 degrees to get Y. So what are the three angles that we know? So John said
miss,
the
miss,
angle at B is 90 degrees because he sees that box in the corner there. We know that one angle is 57. What's the other angle?
miss
What's
108.
DAB?
Oh, miss DAB.
miss,
Wait, miss
51 degrees.
DAB is 51.
D,
Is it
DAB.
not?
108 degrees,
Why
miss.
is it? Why is it?
Miss, because it's the 108 is cut into two, and because EAD is 57 degrees, DAB would be the other part.
Okay, so it's the 108 minus the 57. All right, so add up those three angles then and take
It's
it from 360.
198,
So
and
we're
that would
adding the
take it from
90, the
162 degrees.
51, and the 57, right?
Yes, miss.
yes, Miss.
Yes, that's 198 degrees, and
And we're
from
taking it from
360, which would give us
360.
162 degrees.
It's
All right, so
162.
that is correct. So y is equal to
162 degrees.
162
162.
degrees.
All right, next question. So the next part of the same question. Show all steps in your calculations and give reasons for your answers. So B, the functions f and g are defined by f of x is half x plus 5 and g of x is x squared. So f of x is half x plus 5 and g of x is x squared. So they want us to evaluate g of 3 plus g of negative 3. So how would we word that?
Miss, uh, oh, so we would find what g of 3 is, and then we'd find what g of negative 3 is, and then add them together.
Okay, so do that.
Okay, miss. So that's,
So we're substituting 3 where x is in g of x, right?
yes, miss.
Okay.
So g of 3 is 9, and
Mhm.
g of negative 3 would also be 9. So 9 plus 9 is 18.
Okay, so that's correct. All right, so I wants the inverse of f, the inverse function of f of 6. So how will we work that?
Miss, so inverse of the inverse function of 6 would be 1 over 6. So we would put 1, so where x is,
No,
we would
to find
substitute
the
x.
inverse of the function, remember,
It
there are
wouldn't, oh,
steps. First, we write the function as f of x, and then we rewrite it as y equal, remember? So write the function f of x equal half
yes,
x plus 5. And then we're going to replace that f of x with y.
Miss
So we'll have
Ross.
y, the same function that they give us
Okay,
for f of x, half x plus
Mm.
5, right?
yes, miss.
So y equal half x plus 5. And when we're finding the inverse of the function, we interchange the x and y's. So we would have x equal half y plus 5, or y over 2 plus 5, same thing.
Yes, miss.
So now we're going to subtract 5 from both sides. So we would
So
have
x
x
minus
minus
5
5
is
is
half
equal
y.
to y over 2. And now we're
Yes,
going
miss.
to multiply that
Multiply
x minus 5 by 2. So put it in a
so
bracket,
x minus 5
2 times x minus 5, which is 2x minus 10, right?
minus 10. Yes, miss.
So now we're going to plug in the 6 now,
Um,
where x is.
Okay, miss. So 2 times 6 is 12, minus 10 is 2.
And that is your answer.
Oh,
ah,
Miss, I
okay.
don't understand.
This functions on
eh,
reductions is here.
Who doesn't understand? Somebody said they don't
Miss
understand.
John, I got lost from the start.
You got there
I got lost from the start, Miss.
from the start of I or I.
Miss, I.
All right, so for f to the negative 1 in functions is called the inverse of the function. The inverse of function f. To find the inverse, there are certain steps that we take. So the first step is to replace the f of x. So instead of the f of x is equal to half x plus 5, we would put y is equal to half x plus 5. The next step is to interchange the x and the y. So we would have x is equal to half y plus 5. And remember, another way of writing half y over 2. So x is equal to y over 2 plus 5. Now we're going to isolate the y. We want y by itself. So we're going to subtract 5 from both sides to get rid of the 5 from the right hand side. And we'll have x minus 5 equal y over 2. Now we need to multiply both sides by 2 because we're isolating the y. So when we multiply both sides by 2, on the left we'll have 2 brackets, x minus 5, close, and we'll have y by itself on the right. So they wanted the inverse of f, where x is 2 is, that's why they have the 6 in the bracket there. So wherever x is now in that function, we're going to put 6. So it would be 6. Oh, we'll expand the bracket. So 2 times x minus 5 would be 2x minus 10. So now when we plug in that 6, it will be 2 times 6 minus 10. So that's 12 minus 10, and that's how we get 2.
Okay.
And I says f of g of 2, f of g of 2,
Miss Miss F of G.
Finish.
Yes, Miss.
f of g of 2. So that means we're going to plug in 2
Two in
where
into
x
the
is in the
function
g function,
and a
and
function.
when we get that answer, we plug it in the f function, right?
Missy wouldn't
So
be the Missy. It would be vice versa, or it has to be that way.
that's closest to the 2, we plug it in.
Okay,
So
Miss.
plug it in g, so that will be x squared. So that's squared, which is 4.
4. So you're
And
plugging
that
in 4 into
answer, we're going to plug it in f. So that's half of 4
4 plus
plus
5,
5,
which is 2 plus 5, which is
which is
7.
2 plus 5, which is
7.
7. All right?
7.
7.
Okay. Now,
Mm.
so let's go to the next question. Sorry, wrong slide. So this one is a cumulative table, and
Yes,
it
Miss.
says,
Yeah.
okay,
Miss, it's
table
a
below
graph.
gives the distribution of heights of 400 female applicants for the police service. So the categories for the height: 151 to 155 centimeters, 156 to 160 centimeters, and so on. And it goes up to 185 centimeters. That's the height of the applicants, and the number of applicants. So 10 persons had 151 to 155 in height. 55 of them were 156 to 160, and so on. The cumulative frequency is given. We didn't have to work it out, but just so you understand how they come by the cumulative frequency, remember the cumulative means to keep adding on what you had before. So it accumulates. You start with an amount and you keep adding to that, and then you add to that. So the first frequency was 10. And then the second row had 55. So we add the 10 to that. That's how we get the 65 under the 10. And then we add the 105 to the 65, and we get 170. We add the 110 to 170, and we get 280. That's the pattern. So by the end of all of that, we have 400 in the cumulative frequency, which is correct because there were 400 applicants. The instruction for the graph says using a horizontal scale of 2 centimeters to represent a height of 5 centimeters and a vertical scale of 2 centimeters to represent 50 applicants, draw a cumulative frequency curve of the heights. And it says you're to start your horizontal scale at 150 centimeters. So here is the graph. You probably can't see the numbers too well, but look at the cursor. Look at the cursor. So told us to
Section.
start at 150. So here I have the 150, and then I've written all the intervals that they asked us to, that they gave us um, in the table. So 150, 155, 160, 165, 170, 175, and so on. So the scale that they ask us to use on the horizontal So it's 2 centimeters to 50 applicants on the vertical and 2 centimeters to
to 50
to
applicants.
represent a height of 30 centimeters on the vertical, right? So
Yes.
that was the scale that was used. All right, so now we simply use the table and plot the centimeters with the cumulative frequencies, right?
Yes.
Based on given. So when we did that, we got this O give, which is the cumulative frequency curve, the standard cumulative frequency curve. Some persons refer to it as the S curve. All right. So let's look at the questions now that we're supposed to answer.
Yes, miss.
So to find, it says use your graph. So part B, use your graph to estimate the number of applicants whose heights are less than 170 centimeters. All right, so going back, so less than 170 centimeters. All right, let me see if I can, just for the purpose of this, let me see if I can expand it a little more. All right. Okay.
Yes, miss.
So less than, so it is 170 centimeters. So we go up to where the curve, where it touches the curve, right?
Yes,
And we
miss.
go across. So that's between the two, it's halfway between the 250 and the
100.
300. So that would be 275.
75. Yes, miss.
275 acts. The second part said the median height of the applicant. All right, so the median height. So since it was 400 applicants and half of that is 200, so we go across and we go down. So it's 165,
5.
166, 167. So it's between 166, 167, right?
Yes,
Um,
miss.
centimeters.
Yes, miss.
Uh, the height part I, the height that is 20% of the applicants
It's
are
25.
less than. The height that 20% of the applicants,
It's 25%.
25, sorry, 25%. So 25% is a quarter, right?
Yes, miss.
Quarter of the 400, so that's 100.
Yes, miss.
So that would be, so it's, so each of these tiny boxes represents one. So from 60 to 65. So each two boxes is one. So that's 61, 61, 162, 162.5. And since it's less than, well, this is how we take the reading, right? If it had been more than, then we would subtract that from the 400. And the final question, IV, the probability that an applicant selected at random has a height that is no more than 162. So so no more than would be 162 or less, right?
Yes, miss.
All right, so 162, so that's 1, 2 here. So that would go up to here. I will go across. So each 2 boxes represents 10. So that would be, so halfway would be 5. So from the 162 up and across, that's 95. And remember, it was 400 applicants in all. So the probability would be 95 over 400. And that cancels down to what?
Miss, that cancels down to 19 over 80.
All right, so the probability 19 over 80. All right, back. All right, so we're now, can you see the screen? Can you make out the numbers?
Miss, it's miss for the exponent is hard.
All right, so I'm gonna try and expand it in a bit. So it says, let me expand. Study the number pattern in the below and come and I in your answer booklet. I think that's below. Oh, that's further down, right? Okay. So they would want us to come. So this is I, and I here. So look at the pattern. Study the pattern. So for the 1, it's 0 times 3 squared plus 3 times 2 plus 2, and that gives 8. For 3 to the power of 1, is that, no, sorry, the power is 3 over here, right? So 3 to the power of 3, we have 1 times 4 squared plus 3 times 3 plus 2, that gives 27. 4 cubed is 2 times 5 squared plus 3 times 4 plus 2, that gives 64. And for the 5 squared, 5 cubed, 3 times 6 squared plus 3 times 5 plus 2, and that gives 125. Can you identify a pattern?
Okay, miss. So the multiplier is going up by ones for the first bracket, and then the multiplicand is like still going up by ones, and then for the multiplicand in the second bracket, it's going up by ones, but it starts at 2, and they're just multiplying by 3s in the second bracket.
All right. So okay, but it's not enough to say. Don't look at it vertically. Try to figure it out in relation to the base, because if you know it's going up by 1, suppose they ask you for the 40th term, then you would be lost. You wouldn't have anything to relate it to say, okay, that plus 1 plus 1 plus 1. So you need to know what is the pattern based on this number here, so that any number that they give you, you'll be able to fill in the pattern. So in terms of the 2, what's happening to these numbers? In terms of the 3, what's happening to these numbers? So what I mean by that, 2, right? That's the base. We have a 0 here, right? Which is 2 minus what? The 0 is 2 minus 2. The 3 is 2 plus 1. And then we use back the 2 here. We're keeping this 3 in all of them. So that's a constant. And this 2 is also a constant. So these 3 things are changing. This is changing. This is changing. That is changing. So for each of them, this number is this number minus 2. This number is this number plus 1. And this number is the same number. Whatever is here, that's it. So see there, this is 3 minus 2, 3 plus 1, and 3. This is 4 minus 2, 4 plus 1, and the 4. This is 5 minus 2, 5 plus 1, and the 5. So for any number that they give you, if they ask for the 40th number, we would know that we need to take 2 from the 40, put it here, add 1 to the 40 here, and write back the 40. You get what I'm saying?
Yes, miss.
So if we use n to represent the base, we can determine the pattern for n, which is what they're going to want us to find for I. So based on that now, what would be the pattern in 6 cubed?
Miss, so 6 minus 2
So with our bracket,
bracket 4
okay, so 4 times
times it would be 6 minus 1, 6 plus 1, which is 7.
So 4 times 7 squared bracket
Bracket
plus
plus
bracket.
bracket. I don't Miss, I don't remember how we got the 3 for the second
The 3 is always there.
Okay. And then put back the 6. So 3 times 6
Right. Plus 2. And that would give what?
Miss, so okay.
Just work out 6 cubed and put it here.
36.
Okay, Miss, 36.
Cubed square.
Oh, cube. 6 cubed would be 216.
Okay. And for the 10 now, so for the 10, same pattern. So
Yes,
we'd
miss.
have bracket
Brackets. 10
6
minus 1.
minus 2.
Oh, sorry. 10 minus 2, which would give you 8.
Yeah. 8 times
10 plus 1, which is 11 squared.
11 squared, close bracket,
Close bracket. Plus
plus
3 times 10 plus 2.
all right, and 10 cubed is,
Miss, 10 cubed is 1000.
all right. So here now at I, they want the general formula, right?
Yes, miss.
So we know that for the first term, we take 2 from whatever n is, right?
Yes, miss.
For the second term, what we do, we add 1 to the n. So it will be n plus 1.
Plus 1.
For the third term, we put back n.
Yes, miss.
All right, so it will be n minus 2 times n plus 1 plus 3 times n plus 2. And that gives n cubed. All right, do you understand?
Yes, miss.
Dreshan, do you
Miss, he's not
understand?
on.
He's not on. What happened to him?
Miss, I'm not sure.
Okay, sir. But he's on the screen, man. He just went off. All right. Can you see the bottom? I think the bottom one, we're going to need to go to the board, right?
Yes, miss.
Yes, miss.
All right, so let me see. So read what is there for me.
Okay, miss. In brackets, we have a minus b squared. Well, the squared is outside. So bracket a minus b, and the squared is on the outside.
Yeah.
And then in another bracket, we have a plus b
Mm-hmm.
plus ab outside of the bracket of a plus b.
A plus B.
Yes, miss. Close bracket equals
Okay.
a cubed plus b cubed, or
A
yeah,
cubed
plus b cubed.
plus what?
B cubed.
B cubed.
Yes, miss.
So they want us to prove that this is equal to this.
Yes, miss.
All right. So all right. So a minus b squared. So that would be a minus b times a minus b, and then this ab times a is a squared b, and ab times b is ab squared. All right. So we know that a minus b, a plus b is the difference of squared, right?
Yes, miss.
A squared minus b squared. All right. So a minus b. So this part is a squared minus b squared. So multiply these. We have a times squared is a cubed. A times minus a b squared. Negative b times a is negative a squared b, and negative b times negative b squared is positive b cubed, and then we
Yes,
have this. All right, so can we simplify? So the negative ab squared and the positive ab squared cancel, and negative a squared b and positive, so we're left with a cubed plus b cubed, right? Which is that. All right, so the first thing we did, the a minus b squared, we write it back as a minus b times a minus b times this, and then we realize that a minus b a b is the difference of squares. So we can write that back, and we expanded this, so ab times a is a squared b, ab times b is ab squared. Expanding this now, the a minus b times a squared minus b squared. A times a squared is a cubed. A times negative b squared is negative ab squared. Negative b times a squared is negative a squared b. And negative b times negative b squared is positive b cubed. Simplifying them, negative ab squared plus ab squared is 0. And negative a squared b plus a squared b is also 0. So all we're left with is a cubed plus b cubed, which is what they wanted us to prove
yes, miss.
that is equal to. All right, let me fix back my Let me fix back my my diagram. So that would have earned us that have earned us 3 points, 3 marks. All right. So we have a speed time graph, and it shows the movement of a cyclist. Dreshan still not back?
No, miss.
Dreshan, are you ready to go back? You ready to join us on the screen? All right. So this is a time graph, and it shows the movement of a cyclist. The movement of a cyclist. So using the graph, calculate the acceleration of the cyclist during the first 15 seconds and II, the distance traveled by the cyclist between the
Miss, are you
period
hearing me?
R equals 15 and T equals 15 and T equals 35 seconds. What are you saying, Dreshan?
What, Miss, are you hearing me? What?
I can hear you now, yes.
But Miss, it kicked me out twice, and Miss, since on the tablet, it doesn't say if I'm backstage or not. Miss, I'll send in the chat.
Oh,
Miss,
okay, it's all right.
explain.
Well, you're back now.
Yes, Miss.
You're back now, so that's fine. All right, so let's continue then. So this is a speed time, and it shows the movement of an object over time, the distance traveled, and the time taken. So I is asking for the acceleration of the cyclist. So the acceleration is how much you are speeding up each time. So the acceleration speed time graph for the first 15 seconds. So if you notice, from 0 to 15, we have this is the acceleration, this is the bike accelerating, right? It's the gradient of this line here from 0 to 15 seconds. So that's what part A is asking. So what we need to find, remember, gradient is the change in y over the change in x. So the cyclist move from rest from 0 to 40 on the y-axis, which is the distance traveled, and the speed, and on the x-axis from 0 to 5 to 15. So the gradient would be 40 over 15. Work that out for me.
Miss 3.3.
3.3.
What?
15 doesn't go into 40 3 times.
Miss
Oh,
2
40. Sorry, I have 50.
Miss 2.3.
Remember the change in the change on the y-axis is from 0 to 40. That's 40.
Miss 2.6.
Change on the
2.66.
x-axis is from 0 to 15. That's 15. So 40 divided by 15 will give the acceleration. How much is that? Forty divided by 15.
Miss
Oh, that's
2.6.
2.6.
Okay, so 2.6 meters per second. The unit for acceleration, meters per second squared, sorry. The unit for acceleration is meters per second squared. For II, it wants the distance traveled by the cyclist between 15 seconds. So T is 15 seconds and T 35 seconds. So in this on the speed time graph, the distance traveled is the area below the graph, the area of the space below the graph for that time that they're asking. So they want us to give them from 15 seconds to 35 seconds. So that is from here to here. So this shape is what? What kind of shape is this?
Um,
Miss a
it's a
quadrilateral.
quadrilateral.
What kind?
Miss an irregular quadrilateral.
What kind?
Um,
It's a trapezium.
oh, what?
It's a trapezium, isn't it?
Oh, yes, miss.
Yes, miss.
Okay. All right. So how do we find the area of the trapezium?
It's at the
Miss
parallel
half
side.
A plus B times the height. So add the parallel side and
All right. So
And
in this
half it.
trapezium, the height is what? The height would be this, the distance between the two parallel sides. These are the two parallel sides. So from 15 to 35, that's 20. And the parallel sides are what?
from
From 0 to 40, that's 40.
yes,
And
miss.
0 to 50, right? So
Yes,
it
Yes,
will be
miss.
the 40 plus the 50 divided by 2 times the 20.
45.
How much is that?
It's 900.
900 meters, because it's the distance they want. So
Yes,
remember
miss.
the distance, if you want to find the
900.
distance traveled on the speed time graph, it's the area of the space. Just find out which time period they want, and it will be the area taken up by the shape on that. So if they had wanted this, it would be the triangle, area of the triangle. So that would be half base times height, right?
yes, miss.
All
Half
right,
it.
so the graph below represents the 5-hour journey of an athlete. 5-hour journey of an athlete. So it's from 0 to 5. That's 5 hours on the
5 hours.
x-axis. And
Yes, miss.
the y-axis shows the distance traveled. So that's from 0 to 12. The distance is in kilometers. So the 0 to 12. All right. So I says, what was the average speed during the first 2 hours? So the
Miss
first 2 hours,
It's 12
speed is
kilometers.
distance over time, right?
yes,
Distance
miss.
traveled over time taken. So the distance was 12.
Miss 6
Miss would it be 7?
kilometers.
Oh,
Miss
I was
6
reading
Distance
wrong.
is 12
kilometers.
kilometers. And the time taken was 2 hours.
Miss
So it
6
would
So
kilometers.
12 divided by 2.
so 6
So the speed is 6 kilometers per
kilometers per
hour.
hour.
Right. And II says, what did the athlete do between 2 and 3 hours after the start of the journey. So here
Yes.
is gradually covering distance with time. He's
Yes, miss.
moving, right? Here, time is going, but but there's no change
Yes, miss.
here. So you can say he has stopped or he's resting or something like that.
Yes, miss.
For between these 2 hours here. Um, and the next question says, hold on, let me go back. I. What was the average speed of the return journey? So this is the return journey. So this is where when he's going and then he has stopped or resting here, and this is when he's going back. So on the return journey, how long it took? So it's from 3.5 to 5. How many hours that?
It's
Um,
1.5.
1.5. And the same
One and a
distance
half
because he's
hours.
going back to where he started, right? So it's the
yes.
same 12 kilometers. So the speed is 12 divided by 1.5, and that gives what?
Miss. Um,
12 divided by 1.5,
miss, you'd get 8
8
8.
kilometers per hour.
per hour.
So was he going faster on the journey to or back home? From home or back home? Which one was he traveling faster?
It's back home. It's going back home.
So when he was going, leaving home, he was going at what we got for
Six
that?
kilometers.
6
Six
kilometers.
6
kilometers.
kilometers per hour.
Yes,
And
miss.
back home, he's going 8 kilometers per hour. So you notice which one of the lines is steeper, would you say? Which one has a steeper gradient?
Miss,
This one or that one?
miss the other one. Miss the last one.
The first or the second?
Miss the second.
The second. So when the gradient is steeper, the person is travel or the vehicle is traveling faster, covering more space, more distance in less time. So a steep gradient shows faster movement. All right, so let's go to the next question.
Miss, how much more questions are there?
How many more questions? Just 3 more questions.
Uh, yeah.
Okay. All right. The question says the diagram below shows a triangular region bounded by the lines y equal 1/6 x plus 5, y equal, I hope, let me expand it. I don't want to say the wrong thing. Make sure I'm saying it. So it's so bounded by 3 lines. So this is linear programming, right?
Yes,
Yes,
miss.
miss.
That was
Linear
hard.
programming. So the diagram below shows a triangular region bounded by the lines y equal 1/6 x plus 5, y equal 5/8 x plus 5, and the line HK. Right? So that's the line H from H to K. So it's bounded by this line, which is the 5/8 x plus 5, this line, which is the 1/6 x plus 5, and this line, which runs from H to K. Now, what do they want from us? They want write the equation of the line HK. What is the equation of the line HK?
Miss, where is HQ?
See,
from H to K. So this line.
Okay. Wouldn't equation be y equals 116 x plus 5 and y equals 958 x plus 5?
This line here is the line y equal 5 eighths x plus 5.
Yes.
On the other side
This
now.
line here is the line y equal 1/6 x plus 5. This also bounds the shape. They want you to tell them what is the equation of this line, HK. What's the equation of that line?
It would be y equals 1/6 minus 5 8 x plus 5.
How you come by that, John?
It's because since one line has an equation and the next one has a different equation, so I just put that together except for putting except for saying it twice. I just put it in one equation.
This line and this line and this line are three different lines. They are all oriented in a different way. They have their own equation. Imani, what you say? Dreshan, what you say?
Miss, how do you say it?
Um,
Basically, y equals 6x.
Y equals
Is that how
6x.
it's said? Um, Basically, you'll be putting up. Wait.
mm,
Okay, let me think.
Dreshan, what you say?
mm. It's AK. Mm, mm,
This is the line, this line, this one,
Yes, miss.
going straight down. What's the equation of that line?
This is, don't know.
That's the line x equals 6.
Miss X equals 6. Yes, I was about to say that. I just figured it out.
Are you sure?
Yes, miss.
oh,
Yes.
It runs right through where x is 6. It's
Yes.
a vertical line running through the
oh,
point where x is 6. So HK is the line x equals 6. Next question.
oh.
Write the set of three inequalities which define the shaded region GHK. So since you now know the equations of the
Okay.
three lines, tell me the inequalities that bound the regions based on where it's shaded.
It's
And by
either
that I mean you're going to put in greater than, less than, greater than or equal to, or less than or equal to for those three
So
equations based on where the shaded region
Mm,
I know
is.
the last part, so it's less than okay. Okay. Um.
So start with the simpler line, the simplest line, x equal 5, that line. Sorry, x equals 6. Would we put a greater than sign, a less than sign, greater than or equal to, or less than or equal to?
It's less than or equal to.
Why?
Miss, because that's where Miss the shading is going to the left, so that would mean it's
oh, yes, miss. It's going to
correct.
the
Correct.
left.
So we're shading to the left of this line, so it's less than or equal to. Why not just less than?
Miss, because if it was just less than, it would be a broken line and not a.
Right. It's a straight line, it's not broken, so it's less than or equal to. All right, how about this line? Y equals 1/6 x plus 5.
Um.
What inequality would we put?
Um,
So it's
a
less
broken
than.
line.
Hmm? We're
Oh,
shading below that line,
so it would be less than.
It's less than.
less than. Is the line broken?
No,
No,
miss.
Also,
less
miss.
than or
Less
equal
than
to.
equal
Less
to.
than or equal to. So
It's
we're
less than or
shading below
equal
the
to.
line. So y is less than or equal to 16x plus 5. How about this line?
Okay, miss, you're shading above, so it's greater than or equal to.
Right,
Um,
so we're shading above this line, above.
It's less
So
than.
y is
Miss,
greater
I'm
than or
greater
equal
than.
to 5x plus 5.
5x plus 5.
All right. Oh, let me fix back my. You students have me distorting my. I need
Mm,
to fix them back. Okay, back where you were. So now, geometry and trigonometry. Um,
in,
so we have. Do you realize that that's two triangles,
yes,
one
miss.
over the other? So
Yes,
we have a
miss.
bigger one at the bottom and a smaller one above it. In the diagram above, not drawn to scale, P and Q are midpoints of the sides XY and XZ of the triangle XYZ. So given that XP is 7.5 centimeters, XQ is 4.5 centimeters, and the area of triangle XPQ is 13.5 centimeters square, they want you to calculate the size of angle PXQ, expressing your answer correct to the nearest degree,
Um, I.
and they want the area of triangle YXZ. I want each of you to read over this question for me. Dreshawn, you go.
Okay, miss. In the diagram above, not drawn to scale, P and Q are midpoints of the sides XY and of a triangle XYZ. Given that XP is 7.5 centimeters, XQ 4.5 centimeters, and the area of the triangle XP 13.5 centimeters.
Calculate. Have you read it? All
Got
of it?
kicked out again. He got kicked out again.
Or he's Iman read it.
Okay, miss. Number 11. A. In the diagram above, not drawn to scale, P and Q are midpoints of the sides X, Y, and XZ of triangle XYZ. Given that X equals 7.5 centimeters, XQ equals 4.5 centimeters, and the area of triangle XPQ equals 13.5 centimeters squared, calculate I, the size of angle PXQ, expressing your answer to the correct and expressing your answer correct to the nearest decimal. Oh, the size of angle PXQ, expressing your answer correct to the nearest degree. I, the area of triangle YXZ.
Okay, so how do we approach this?
Messi said he got back. He's backstage and that his internet chipped out. Okay.
If I look on the here, expression the answer.
Yes, I'm asking how do we approach this?
Is that a scaling triangle?
Hmm?
Does that make that a scaling triangle? So all the sides are not even.
Is scaling
Oh,
PXQ. So
so I'm
XP 7.5, XQ is 4.5. So we would want YZ, or is it no? Wait, we know that XP 7.5. Oh, but it's not a right angle triangle. Okay.
wait.
it's
Do we
not a
not need?
right angle triangle.
Miss, miss, do we not need to know how to find out which numbers it, like which, like what P, X, and Q are, miss?
Huh?
Miss, do we not need to find out what's the angle of P, X, and Q, like the angles themselves?
No.
Okay.
We can use the sine rule.
Okay, miss, how do you use this triangle again?
Opposite over hypotenuse.
So the opposite of the hypotenuse is
Mm-mm.
No, I'm not talking about the trig functions. I'm talking about the sine rule or the cosine rule.
Oh, sine theta.
isn't that the sine?
Miss the one that
So
says sine theta.
what are the lengths that we know?
Miss,
Miss,
we know XP and XQ.
Right. As a matter of fact, since they tell us since they tell us the area of the smaller triangle. All right, focus on the smaller triangle, the PXQ or PQX, whatever. If we fill in the lengths of that triangle, right? So they're saying XQ is 4.5. So sketch the diagram, put in the 4.5 centimeters where XQ is, and the 7.5 where XP is. But guess what? They told us what the area of that small triangle is. So we can use the formula for the area of the triangle, fill in what we know, and find the angle. So area of a triangle, remember there are three basic formulas for area of a triangle. If it's a right angle triangle, or if we know the height of the triangle, we can use the half base times height, right?
miss,
This we can't use that in this case because it's not right angle and we don't know the height. If we knew all the sides, all three sides, we could use Heron's formula. The other formula we can use is half AB sine C, where A and B are two sides of the triangle and the angle is the angle between those two sides, right? So
yes.
since we know XQ is 4.5 and XP is 7.5, and we're trying to find the angle between them, and they told us the area is 13.5 centimeters squared. Just plug that in. So half times 7.5 times 4.5 times the sine of theta would give 13.5. And then we'll work out the ones that we know already. So half times 7.5 times 4.5. Divide the 13.5 by that. And then since it's the angle we want, we know we're going to put second function, right? Or shift or inverse, whatever your calculator has. So it's half times the 7.5 times the 4.5. And we're going to divide that into the 13.5, which is the area. The number that we get, we're going to press shift and sign.
Mm.
and tell me what you get for that.
Okay, Miss. Miss. Okay, hold on. 13. So it would be Miss. So it would be or inverse 5/16.8. So
Yeah,
okay.
and you get what?
53.13.
All right, so 53 degrees, that is the angle. And you realize that both triangles have the same angle, right?
Yes,
The
Miss.
small triangle and the big one, they both. So that 53 degrees also applies to the big triangle. So the second part of the
Yes,
question
Miss.
wants us to find the area of the big triangle. Now there are two ways we could do it. We can use that same formula, half AB sine C. In this case, since they
We would have to
told us
find the
that
amplitude.
the small one is the midpoint of the bigger one. So the bigger one is twice the length of the small one, right?
Yes, Miss.
So it would be, if we're using that same formula, half AB sine C. For the big one, it will be, we'd have to double the 7.5 and double the 4.5 for the lengths, for
Yes, Miss.
XZ and for XY. So it will be half times 9 times 15 times the sine of theta. And we know that theta is 53. We just work it out, right?
Yes, Miss. Yes, Miss.
So work out all of that. So half times 9 times 15 times the sine of 53 degrees. That will give you the area.
Miss, Miss, that's weird. Miss, I got
Okay, sir.
26.72. Which means
Pardon me?
27. Miss, I got 26.72.
For the
Oh,
area of the big triangle?
that's Miss. That's
67.5
not
sine
No,
50.
that's not what you
Miss,
should
I
get.
got 53.9
Centimeters square.
centimeters squared.
Centimeters.
So we could round that to 54 centimeters square.
I mean, how should I do it? Miss
Remember,
inverse.
we double the lengths because since the small one, the lengths are touch the midpoint of the big one. So the big one is twice the length of the small one.
Yes, Miss.
So the length for the big one is 4.5 times 2, which is 9, and 7.5 times 2, which is 15. So we use the area of the triangle, half AB sine C. So half times 9 times 15 times the sine of 53, because we just work out that the angle is 53 degrees.
Yes,
So
Miss.
that's one way to find the area of the big triangle. Another way would have been, since we know that the two triangles are similar and the big one is twice the length of the small one, if we know the area of the small one, the big one would be area times the square of the scale factor. So the scale factor is 2 because the length is twice the small one. We square the 2 and we get 4. So the area of the big one is 4 times the area of the small one. So we could have just worked out the 13.5 times 4,
Yes,
and
Miss.
that would have given us the 54 centimeters square. So that's another way we could have worked it. Do you understand?
Yes, Miss.
So let's go to the last question.
What's the last question now? Oh,
Hold on, okay. So this question, um, the figure SJKM above, not drawn to scale. Let me expand it. Hold on. Right, so you can see it better.
yes, miss.
It's not drawn to scale. It's a trapezium with SJ parallel to MK, and the angle MJK is 124 degrees, and MSJ is 136 degrees, and SM is equal to SJ, which is 50 meters. Calculate the size of A angle SJM and B angle JKM. Imani, I want you to read it, and then I want John to read it,
Okay, miss.
and I want Drayshawn to read it.
Okay, miss. B. The figure SJKM above, not drawn to scale, is a trapezium with SJ parallel to MK, angle MJK equals 124 degrees, angle MSJ equals 136 degrees, and SM equals SJ equals 50 meters. Calculate the size of A. Angle SJM, B. Angle JKM. There's more. Can you slow down, please?
Okay, John.
Okay, B. The figure S SJKM above, not drawn to scale, is a trapezium with SJ parallel to MK. Angle MJK equals 124 degrees. Angle MSJ equals 136 degrees. And the SM equals SJ equals 50 meters.
Calculate.
Yeah.
Oh, calculate calculate the size of angle of A. Angle SJM, B. Angle JKM.
All right, Drayshawn, your turn.
Okay, miss. The figure SJKM above, not drawn to scale, is a trapezium with SJ parallel to MK. Angle MJK is 124 degrees and angle MSJ 136 degrees. And SM is equal to SJ equal 50 meters. I calculate the size of angle SJM, A angle SJM, B angle JKM.
Okay. And let me just welcome those who are joining on the chat. Some persons are late tonight. Young DK, how you manage late tonight? Akila, welcome. Akila. And Danmore Carr, welcome. She said she had no internet the whole entire day. It's better to be late than never. So let's see. It's a trapezium and they have cut it up into two triangles. And SJ is equal to SM, so those are 50. So one of the triangles is isosceles then, right? All right, so they want angle SJM. So that's this angle here, from S to J to M. So how would we
Yes, ma'am.
find this angle? Any ideas on that?
Let's let's have an angle SJM.
Speak up, John.
Uh, Miss, do you want it in meters, Miss? Oh, there is one.
Do we measure angles in meters?
No, Miss, I just realized.
Okay. What's the unit that we use to measure angles?
Miss degree.
Hmm?
Degrees, miss.
Degrees, okay.
Since
So
SM
we're
is
gonna want the angle
Kinetic,
in, we can measure angles in radians also, but these angles are given in degrees. So how are we going to find this angle here? From S to J to M, this one.
Um,
What kind of triangle did we say this is?
Miss Isaac.
Isosceles.
All right, so it's
it's
isosceles, so
isosceles.
these two sides are equal, which
Miss.
means these two angles are equal.
Yes, miss.
Miss.
Oh,
Miss, what
Okay,
do
so
I have
how
to
we're going to find this angle?
Um, miss, we would use one of the trig ratios.
No, ma'am, trig ratios apply to
Oh,
right
sorry,
angle
the
triangles.
right angles. Never mind.
angle.
This is
How?
isosceles and it's not a right isosceles. How we're going to find this angle?
How? Oh, Miss, would we have to convert the meters to degrees?
Convert it to?
Miss, I was asking if we're going to convert meters to degrees.
I'm not hearing you now, John, for some reason.
Miss, I was asking if we're going to have to convert the meters to degrees.
We don't convert meters to degrees.
Okay, Miss.
All right, so listen up. So this triangle is isosceles. We know that because they tell us that this is 50 and this is 50 meters as well. So these two angles are equal. So if we take the 136 from 180 and
Miss,
divide the answer by 2, we're going to get each of these angles.
44. Miss, for me, Miss of what?
So
Miss of
180
44 divided
minus 136 degrees,
44 degrees, Miss.
and we divide it by 2 because
44
it's two
degrees.
equal angles.
It's
Yes, Miss.
22,
So
22
each of
degrees.
these angles is
22
22
degrees.
degrees. All right. So that's the
Miss,
answer for, for IA.
Miss, can I work out the next one, Miss? Miss, can I work out the next one?
So B1's angle JKM.
Yes, Miss, I can work it out.
All right. Tell me, John.
Okay, so Miss, first we're going to do 124 degrees from 180 degrees. Miss, and you would get.
So you're saying take 124 degrees from 180 degrees and you'll get this angle here.
No, wait, no, Miss. Miss, we get
Huh?
K, Miss, we get KRM, Miss. Oh wait, Miss.
J
But
to K to M. They want this angle.
so Miss, we already know J and M, Miss. 22.
Okay, so we know that this is 22
Yes,
and this is also 22.
56,
So how we're going to find this?
'Cause thinking about doing
23.
the 124 plus 22.
John, you sound like you're the weird on Mobile talk to me. I'm Mobile.
No, Miss, I was saying 124 plus 22, Miss. I said, oh yeah, sorry, Miss
But
plus
why are we adding the 22 and 24?
Miss because it asks for JKM.
23.
And why are we adding the 22 to 124?
Miss,
There
Miss
must be a
because
reason.
yes, Miss because we already know the
This is the 22, this, and this is 22. So how do they relate to this triangle here?
Miss. Miss no
How
word,
we
Miss
make the
there's
connection? How do we
Miss no
make that
word.
connection?
Um, miss,
So
would it
then
be that they're what do you call it?
they are what?
Miss there's
Oh
scaling.
no,
Miss is a scaling triangle.
What is the importance of the fact that these are parallel lines, these two? Why is that important?
Means it would be a Z's, what you call it, Z angles, alternate angles.
So what would be the z angle or the alternate angle?
Means the alternate angle would be the 22 in the SJM and the 22 at JMK.
Correct, correct. So this is how we know that this is 22. So these are the two parallel lines. And whenever we have a transversal cutting across two parallel lines, we have alternate angles being formed. Some persons call it the Z angle. This is the Z. That's the Z. So this angle here is equal to this angle here. They're alternate angles. So that's how we know this is 22. And that's why we're going to add the 124 plus the 22 and take it from 180 to get this angle. Because now we can focus on the triangle. Now that we use this to get this, we can now focus on the triangle. So add that up, 124 degrees
124
plus 22 degrees, and
gives you
take it from
142.
180 degrees. And we get what?
So we get 34 degrees.
34 degrees. All right, let's look at this. The second part of this question,
Oh, there's more.
the last part of this question, part II, calculate, and this all of this is worth 15 marks.
Wow.
So this is worth 6 marks, and what we just worked was worth 3 marks.
What?
1.5 marks each for these two, 3 marks each for these two. So it says calculate, expressing your answer correct to 1 decimal place, the length of MJ, and then B says the length of JK. So we're going to need to find MJ and then JK. All right, so how are we going to find MJ? We're not going to use the trig ratios because those apply to right angle triangles, and none of these is a right angle triangle. So what are we going to do?
Um, so
So we're going to use the sine rule.
it's the same rule that we used for.
No, not the area, not the one with area of the triangle with half AB sine C. The sine
Oh,
rule says A over sine A is equal to B over sine B. That means any angle over the side that's opposite to it is equal to another angle over the side that's opposite to it. So since we want MJ, the angle that's opposite to MJ is 136, right? We can use this angle here, the 22, and the side that's opposite to it, which is 50. So we can put MJ over the sine of 136 is equal to 50 over the sine of 22. So write that down. That's the sine rule. So MJ over the sine of 136 degrees is equal to 50 over the sine of 22. So fill in those values now. Find the sine of 136. Find the sine of 22. And we're going to cross multiply. So it's 50 times the sine of 136 divided by the sine of 22. And you will find the length of MJ.
The
So,
body?
Miss, so sine 169 is 0.69 So MJ
Sine 159,
one
136.
136. What was I saying? 136 is
Mm-hmm.
0.358.
0.69.
So multiply the 50 times that
It's
and
50
divide the answer by the sine of 22.
Which
times
is
22.
0.37.
That
0.37.
says 1.336. It's 1.336.
How you guys getting those answers?
Miss, I didn't get my answer as yet.
This is it
But
negative?
I hear
Nine?
Drishan give. Okay, so it's the sine of 136 times 50 divided by the sine of
I got
22.
93.2.
Okay, and they want it correct to one decimal place. Remember that?
Yes, miss.
So it will be what then? Oh, well, that's it, right? One decimal
Yes, miss.
place. Okay. And now they want JK. So can we use the same sign rule? Do we have
Miss,
we have
miss, you
an
said JK?
angle? They want JK though. Yeah,
Yes,
JK. We know this angle and we want this side in front of it. We know this angle and we just found MJ, right? So
yes,
we can
miss.
use that. Yeah, so we can
We can use the same.
um so JK, so here's what you're writing now. So JK over the
Yes,
sine
miss.
of 22 is
Yes,
equal
miss.
to 90, what you say got 93 point something
93.2.
over the sine of
124.
this was what again?
Oh, wait, no, not 124.
34.
34. Yes, miss.
Yeah, okay. So that's what we're writing. MJ over the sine of 22 is equal to 93.2 over the sine of 34. And then you're going to work out the signs and cross multiply.
Um,
So 34.9 divided by.
No, so multiply the sine of 22 by the 93.2
Yes, miss.
and then divide that by the
That is.
sine of 34.
Okay, miss.
so I got 88.41.
Miss, I got
You
63
sure?
point. Miss, I got 63.4.
Yeah,
Ah,
62.4 is. What did you do wrong, Dreshan? Did you have um the 93.2 times the sine of 20 divided
22.
by the sine of 34?
Wait, Miss, I wrote 32. Wait, Miss, it's supposed to be 22.
Remember, the sine rule says A over sine A is
Oh,
equal to B over sine
Miss,
B.
my
That's the
device
sine
is at
rule.
5. Miss, my device is at 5. Um,
We're wrapping up now. We're wrapping up. We're in the final minutes now.
charger. Oh, never mind. Charger's out there. Oh,
Okay, so are we clear?
I guess so. I wrote
Yes, miss.
32. It should have been 22.
All right, so that was the final question. Let me adjust my slide um, back to size. So how did we do?
My device is at 5.
How did we do
Miss, you
tonight?
have 20 minutes left. That's so amazing.
Yeah, we had 20 minutes left. Um, So I'm gonna need to get more and more questions for you guys, really. Last night when we did the 60 questions, we had time left too, don't it?
Yes, sir.
Yes, miss.
Around 15 to 20 minutes.
15 minutes. Yeah. 15 minutes left.
Right. We did all 60 questions and we had about 15 or 20 minutes left. I don't want to pass the 60 questions for the midnight oil class though.
Yes, miss.
But definitely for the paper two, we can add more questions. Because of course we're going to get sharper and sharper as we go along, right?
Yes, miss.
Yes, we are.
Please remember, we're not just solving math problems, we're changing lives. Talk over here. What?
Again,
Please remember, we're not just solving math problems, we're changing lives.
we're changing lives. We're absolutely changing lives. Thank you for that, sir. And thank you
You're
for
welcome.
always reminding us of that fact. So, scholars, I will see you on Monday. And just so you remember, I'm going to be playing the short video with the schedule of classes for you. All right.
Okay, miss.
So,
Night, miss.
me temporarily remove myself so I can put.
Not much hard. I'll leave this
Hello, CSEC math students. I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like math? Thank you. Now, another important question. Have you ever gotten a math wrong simply because of making one little mistake? I'm sure you have. Thousands of other students. Now, in this series, we're going to be looking at the common mistake that students make with all the topics in CSEC math. We're going to look at the common errors, demystify everything. Make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello. Did you know that most times when students get problems wrong, mathematics is as a result of one single error or one mistake? Well, we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.